So question 98 now, all about the intersection of circle and the line to make a tangent. The first thing I want to do is get a little picture in my head of what's going on. So I'm going to actually draw a little sketch of this circle. In order to do that, it's going to help me. It's not strictly necessary for this question, but it's going to help me to put the equation of a circle in the standard form so that I can see the center and radius. So there's the equation of the circle. So I'm going to take the x squared minus 6x and complete the square on that, and then the y squared plus 10y and complete the square on that. So completing the square on the x squared minus 6x is x minus 3 squared minus 9, and then the y squared plus 10y, completing the square on that. So tidying that up gives me a nice little 100 there, which is my r squared. So what we're looking at is a circle with center at 3 minus 5 here, something like that, radius of 10. And what we're trying to find is tangents to the circle, which are of this form. So they cross through the y-axis at minus 20 down here somewhere. So I've got one tangent that might look like that, and the other tangent that might look like that. So that's what I'm trying to do. I'm trying to find the gradients of these two lines. The k is the gradient of the two lines. So in order to do that, I need to use the fact that the tangent and the circle intersect each other. But when we try to find the points of intersection, we're getting equal roots. So remember that for a second. So what I've done here is to find out an equation which expresses where the line and the circle intersect. So what I've done is I've put the value of kx minus 20, I've substituted that in for y here and here. So this is the resultant equation that I get when I do that. So it looks a bit messy. It looks even messier when I multiply the brackets out. Then I'm going to group the like terms. And now I've got a quadratic equation, which isn't very neat, but I've expressed the coefficients of x squared here and x here. So what's happening now is that this equation is the one which has equal roots, because the line is a tangent, or each of the lines is a tangent to the circle. So for this equation, then b squared minus 4ac, the discriminants must equal 0. And what is a, b, and c? Well, b is that, a is that, and there's c. So if b squared minus 4ac equals 0, then that's what this equation looks like. Again, it's not very neat, but we can cope with that. Multiply the brackets out and group like terms, and we get something which is a little bit smarter. We could use the quadratic formula on that, and if we were asked to find the exact values of k, then we would need to do that. But we're not asked to find the exact values of k, so we can write them in decimal form. So what I've done is I've just used my calculator, the equation solver, to solve that equation. That's the quickest way to get the two values of k, 0.778 and minus 1.767. So that's the answer to the question. Just thought I'd, courtesy of GeoGebra, show you what the neat version of the diagram looks like, which is this one. So there's the circle in red, and there's that's the blue line here is the graph of y equals 0.778x minus 20, and the green line is y equals minus 1.767x minus 20, both going through the y-axis at -20 and both tangents to the circle. Okay, so that's the answer to the question.